For a long time, the moon was forgotten. After the historic Apollo missions by the United States and lunar missions by the former Soviet Union, humanity's focus shifted toward more distant horizons: Mars, Jupiter, exoplanets. It was as if our natural satellite had lost its relevance, an already explored setting, a stage with nothing new to offer. But quietly, this scenario began to change. Discrete launches, low-profile missions, and then suddenly the world realized the moon was back. In the spotlight, NASA revived its lunar dream with the ambitious Artemis program. SpaceX joined the game with technologies that seemed pulled straight out of science fiction. And on the other side of the globe, China launched a true scientific and strategic offensive that reignited a space race we hadn't seen in decades. But what triggered this shift? Why did everyone suddenly turn their eyes back to the moon? And what is truly hidden on its far side, the part we never see from Earth? This is the story we're going to tell you now, one filled with silent progress and astonishing discoveries. China's arrival on the moon's far side began with a modest lunar program in the early 2000s, but with a crucial difference: a clearly defined plan, progressive, and with specific goals. Through the China National Space Administration (CNSA), the country launched a series of missions called Change, named after the Chinese moon goddess. Each stage was carefully designed to achieve not only scientific and technical objectives, but also strategic ones. In 2007, the Change 1 mission achieved something remarkable. It mapped the entire lunar surface in 3 dimensions and studied its chemical composition. Soon a discovery caught the world's attention: traces of helium-3. This isotope is rare on Earth, but potentially abundant on the moon, and many see it as the future of clean energy production through nuclear fusion. A small amount of helium-3 could generate an enormous amount of energy without producing the radioactive waste associated with current methods. Even better, fusion using helium-3 generates virtually no radiation, making it an extremely safe energy source. 3 years later, in 2010, Change to raise the bar. With more advanced cameras and an orbit just 15 kilometers above the surface, it identified potential safe landing sites for future missions. China was paving the way with millimeter precision. But it was in 2013 that a true turning point came. The Change 3 mission accomplished something not seen since 1976: a soft landing on the lunar surface. The lander touched down in the Mare Imbrium region on the visible side of the moon and released a small rover named U2, or Jade Rabbit, a direct reference to Chinese folklore. This rover didn't just take pictures and analyze rocks. It also carried the first ultraviolet telescope ever placed on the moon, making China a pioneer in using the moon as a platform for deep space observation. The mission was so successful that China became officially recognized as one of the few powers capable of operating robotic vehicles on the lunar surface. But China wanted to go further. Literally, the next step would be bold: reaching the far side of the moon. That hemisphere is always facing away from Earth, an unexplored and mysterious territory until then out of reach. No mission had ever operated there. The reason was both simple and challenging: the complete lack of direct communication. Without line of sight to Earth, how can you control a rover? China's answer sounded like science fiction. They launched a satellite called Qiqiao, strategically positioned at the Earth-Moon Lagrange point 2. This point acts like a cosmic balance where Earth's and the Moon's gravitational pulls cancel each other out, allowing a satellite to remain stationary and relay signals between the Moon's far side and mission control on Earth. For the first time in history, a rover could now actively operate on the far side of the Moon, a feat of engineering that opened the door to a new era of lunar exploration. In 2019, China wrote another remarkable chapter. The Change 4 mission softly landed in the von Karman crater, located within the South Pole Basin, one of the largest and oldest impact structures in the entire solar system. This location is a natural laboratory preserved for billions of years, and since it faces away from Earth, it's one of the few places in the solar system that remains in complete radio silence, making it perfect for astronomical observations and delicate experiments. Less than 12 hours after landing, the Yutu-2 rover, an improved version of its predecessor, was already exploring this virgin territory. The images it transmitted revealed a landscape completely different from the moon's visible side. No lava seas here, instead, a rougher terrain with many more craters, mountains, and irregularities. This contrast has always intrigued scientists. Why are the two sides of the moon so different? Analyses conducted by Yutu-2 revealed that the soil on the far side has a much thicker crust, formed by ancient impacts and materials that never went through volcanic recycling. These are pure records of the moon's history untouched by time. But it wasn't just the rocks that drew attention. In 2020, during the Chang'e 5 mission, China once again surprised the world, this time with an even more symbolic achievement, returning lunar samples to Earth, something that hadn't happened in over 40 years. Among the small amounts of soil brought back, there was something that caused a huge stir in the scientific community. A new mineral was identified, named changesite. Why? This substance had never been catalogued before, and most fascinating of all, it contained traces of helium-3. Just 40 grams of helium-3 could generate the same amount of energy as 5,000 tons of coal. The moon may contain over 1 million tons of this element. If extraction technology can be developed, this lunar resource could supply Earth's energy needs for centuries or even millennia. That's why, since its earliest missions, China has invested heavily in mapping the distribution of helium-3 across the lunar surface. To many experts, this quest is comparable to the gold rush of the 19th century, only on a much larger scale. A true race for the fuel of the future. But the moon's far side still had more surprises. In mid-2019, the Yutu-2 rover detected something unusual, a shiny substance at the bottom of a small crater. Unlike the surrounding terrain, this material reflected light in a strange, almost metallic way. As expected, the internet went into a frenzy. Could it be a life form? Extraterrestrial? Liquid? Some kind of alien structure? The mystery deepened because the images were not released right away. When they finally went public, they showed a dark glassy substance. Analyses confirmed it was impact-melted material, a rock that had melted from the heat of a collision, rich in minerals like olivine and pyroxene, very similar to samples from the Apollo missions, but found in a completely new, untouched region. Even though it wasn't alien, the discovery held enormous scientific value. Every lunar fragment is like a page in the history of the solar system. And if you think China stopped there, think again. One of the biggest surprises came from a discrete biological experiment aboard the Chang'e 4 mission. Inside a small container the size of a paint can were cotton seeds, potato seeds, fruit fly eggs, and yeast, a mini ecosystem carefully assembled to test something bold. Could life begin to grow on the moon? In January 2019, scientists announced that one of the cotton seeds had sprouted. For the first time in history, a plant had grown on the moon's surface. It survived only a few days due to the extreme lunar night temperatures, which can drop to -70 degrees Celsius, but the symbolism was undeniable. That tiny plant represented a giant leap, the possibility of starting, even in a rudimentary way, agriculture beyond Earth. This kind of experiment is crucial for the future of human presence in space. Permanent bases on the moon or even Mars will require growing food locally. Shipping supplies from Earth is not sustainable long-term. Every test like this helps pave the way for a future where life can flourish beyond our home planet. As science advanced, international reactions began to emerge. Many scientists around the world praised China's achievements. Even Jim Bridenstine, the NASA administrator, publicly congratulated China. However, not everything was applause. The growing success of China's lunar program also raised concerns among Western space agencies. For political reasons, U.S. law prohibits direct cooperation with China on space projects. However, there was an indirect flow of scientific data, especially through European partnerships. The ESA, for example, contributed instruments to the change missions. But even with limited collaboration, the moon's far side began to spark something beyond scientific interest, the fascination of collective imagination. Due to its isolated and mysterious nature, this region became fertile ground for conspiracy theories. On social media, people began making claims about unusual structures, unidentified objects, and supposed hidden artifacts. One of the most emblematic cases was the so-called lunar hut. In 2021, the U-2 rover spotted a cube-shaped silhouette on the horizon. The blurry, distant image quickly went viral. Had the rover found a monolith, an alien building, a dimensional portal? The nickname Mystery House caught on, but as the rover got closer, reality took over. It was just a rock with a peculiar shape. Curiously, it resembled a crouching rabbit, a poetic coincidence, since U2 means jade rabbit. The story went viral, turned into memes, and even without any aliens involved, it reminded us how the moon, especially its far side, still captures the human imagination. Even with memes, mysteries, and exaggerations, China remained focused on its real objectives. While the world speculated about lunar huts, the change program continued advancing with a solid and well-structured plan. One of its boldest projects is already underway, the construction of a robotic base at the lunar South Pole, and the most impressive part. This base will be built using the moon's own materials through 3D printing technologies. The idea is to turn lunar soil into raw material to build habitable structures, laboratories, and research areas. This plan isn't just on paper, it's already following a well-defined timeline. In 2024, the Chang'e 6 mission returned with samples from the far side of the moon, another unprecedented achievement. The Chang'e 7 and 8 missions, planned for the end of this decade, will have even more ambitious goals: to search for water, ice at the lunar poles, and test extraction and construction technologies using local resources. The presence of water is, without a doubt, the most valuable asset in this new lunar race. Previous missions like India's Chandrayaan-1 and the American LCROSS had already confirmed deposits of ice in craters that never see sunlight, true cold traps where water has remained preserved for billions of years. This ice can be turned into drinking water, breathable oxygen, and even rocket fuel by separating its hydrogen. With water, constant solar energy on nearby highlands, and a perfectly silent environment for scientific experiments, the lunar South Pole has all the ingredients for a permanent research base. It's no wonder both China and the United States are targeting exactly the same region. And this is where the most sensitive geopolitical scenario of this new space era begins. China has already declared its intention to build this base with international partners, but outside the framework of the Artemis Accords led by the United States. On the other side, the U.S. is trying to regain its leadership with the Artemis program, which aims to land humans on the moon again by 2027, relying on private companies like SpaceX and allies such as the European Space Agency. China, meanwhile, has its own target to send its takonauts, as its astronauts are called, to the lunar surface by 2030. To achieve this, it's developing a new rocket, the Long March 10, and its own lunar lander. The competition is becoming clear. Both countries intend to establish a permanent presence in the same strategic areas of the moon, sunlit ridges near craters with ice, sand. Inevitably, that could lead to conflicts of interest. The Outer Space Treaty, signed in 1967, prohibits any country from claiming ownership of celestial bodies like the moon. However, the document is vague when it comes to resource extraction. This means that whoever arrives first, sets up infrastructure, and masters the logistics could, in practice, set the rules for usage and exploration. That's exactly what makes this race so different from the one we saw in the 1960s. Back then, the contest was about prestige, of flag planted, a photo on the surface, one small step for man. Today, the race is about resources, energy, knowledge, and above all, geopolitical influence on a planetary scale. The the moon is back in the game. And this time, it's not just a symbolic destination, but a real springboard for the future, an outpost for longer missions, a power plant, a laboratory beyond the reach of Earth's noise, and perhaps a new territory for humanity to occupy. The far side of the moon, which remained invisible to us for billions of years, is now illuminated by technology, ambition, and curiosity. Whether it's the search for helium-3, the presence of frozen water, or the perfect silence for science, it has become the ultimate testing ground of the new era of space exploration. And whatever is discovered there, whether a new rock, an ice deposit, or a transformative energy resource, could change not only the course of science, but the very fate of Earth itself. The future of our civilization may very well be taking shape right now in the most silent and mysterious place in the solar system. So, do you also believe that humanity's future might begin on the moon? If content like this fascinates you, as much as it fascinates us, then subscribe to the channel right now and turn on notifications so you won't miss the next episodes of this new space race. Leave a like if you learned something new today, and share this video with that friend who's always looking up at the stars. Thanks for watching, and see you in the next video.